In this video, we're going to work example problems related to proving that two lines are parallel. Now, remember, we talked about how trying to prove that two lines are parallel just strictly with our fundamental definition of what parallel means, and that you have two lines contained in a plane that don't intersect, with just that information, it would be virtually impossible to prove that the lines are parallel. And so what we do in order to prove that two lines are parallel is that we cut the lines with a transversal. And the main result of this is the 8 angles that come out of the two intersection points. And by analyzing certain relationships between these angles, we can determine if lines L and M are parallel. Now, there was also other techniques that we learned in this section that aren't directly related to just analyzing the relationships between the angles that would allow us to determine if the two lines are parallel. So we know that if both of these lines would be perpendicular to any transversal, as long as they're perpendicular to the same transversal, then that means the two lines must be parallel. And also we learned that if this line is parallel to some other line, say line P, and this line is also parallel to that same line P, then this line and this line must be parallel. So those were the tricks we learned in this section for trying to figure out if two lines are parallel. Now, in regards to analyzing the relationships between these angles, what relationships between the angles did we talk about that would allow you to definitively prove that the two lines, in this case L and M, are parallel? Well, there's different options, but if you can show that just one pair of corresponding angles are congruent, then the two lines must be parallel. If you can show that just one pair of alternate interior angles are congruent, or just one pair of alternate exterior angles are congruent, then the lines must be parallel. Either of those, either or. Now, there's other ways. If you can show that just one pair of interior angles that are on the same side of the transversal are supplementary, then it proves the two lines are parallel. And same with just one pair of exterior angles on the same side of the transversal being supplementary. So any of those ways, just one of those, just one, proves the lines are parallel. And we talked about, and it's interesting to think about how if you, like, for example, if you find just, the idea is if you find just one pair of, say, corresponding angles are congruent, then that constrains everything else in the sense that once you find that, then that means all the other corresponding angles must be congruent. Alternate interior and exterior angles must be congruent. The supplementary constraint must be true, etc. Okay, so lines L and M are cut by transversal V. On the basis of the information that we're given, determine whether L must be parallel to M. Okay, so if the measure of angle 1 is 107 degrees and the measure of angle 5 is also 107 degrees, so those two angles are congruent, does that mean that L must be parallel to M? Well, angle 1 and angle 5 are corresponding angles, so we found just one pair of corresponding angles are congruent, so L must be parallel to M. That's it. Okay, what if angles 2 and angle 7 are congruent? Well, we can see those are alternate exterior angles. We found if just one pair of alternate exterior angles are congruent, the two lines are parallel. Okay, what if the measure of angle 1 is 106 degrees and the measure of angle 7 is 76 degrees? Well, 106 plus 76 is 182. So that means these two angles aren't supplementary, okay? Now, angle 1 and angle 7, how are those related? Those are exterior angles on the same side of the transversal, but they're not supplementary. Again, because 106 plus 76 is not 180. So does that mean that we can say that L is not parallel to M? Well, let's think about it, because we never officially looked at, if we have if P, then Q. We proved in this section that if you have, you have two lines cut by a transversal and you find that a pair of exterior angles on the same side of the transversal are supplementary, that's the P, the hypothesis, then the conclusion is that the two lines are parallel. Okay? But what are we talking about here to be able to make this statement? Well, we're saying that if two a pair of exterior angles on the same side of the transversal are not congruent, then the two lines are not parallel. So how is that related here? Well, that's the contrapositive. If not Q, then not P, right? If a pair of exterior angles on the same side of the transversal are not congruent, that's not Q, then not P. Well, we know that based on the indirect proof, we assume that the contrapositive and the original conditional are the same. They're either both true or both false. Well, we know this is true, so the contrapositive is also going to be true. L is not parallel to M. Okay, what if angles 1 and 4 are congruent? Okay, well, those are vertical angles, but we know that whether or not L and M are parallel, the vertical angles are going to be congruent. Like we could have these two lines cut by this transversal. Okay, so there's angle 1, 2, 3, 4, 5, 6, 7, 8. Well, angles 1 and angles 4 are still congruent, and these two lines are certainly not parallel. But you can see, though, that, so does that, what conclusion can we give? Can we say that the lines aren't parallel? Well, no, we can't. It doesn't tell us anything. Again, because these angles are going to be congruent no matter what the relationship between L and M are. So there's no basis. Okay, what if the measure of angle 3 is 113.5 and the measure of angle 5 is 67.5? So, okay, let's see. Does that mean these two angles are supplementary? So we've got, no, they're not supplementary, and they are, it's close, but they're interior angles on the same side of the transversal, so no. L is not parallel to M. Okay, what if angles 6 and 7 are congruent? Those are just vertical angles. It doesn't tell us anything. Okay, in this problem, we want to name the lines, if any, that must be parallel under the given conditions. So we've got multiple potential like parallel lines and transversals, so this can get confusing. But we talked about how to approach something like this. So, okay, what if angle 1, if we're told that angle 1 is congruent to angle 20, then what could we conclude? So angle 1 is congruent to angle 20. So the way you approach this is you state, okay, what lines are involved in creating angle 1, and then you state what lines are involved in creating angle 20. So with angle 1, lines P and L are involved, and with angle 20, lines Q and L. So what you noticed is that there's a common line there. That was line L. Between these two angles, there was the common line L. That means L must be the transversal, right? Because if you think about just the normal example of two lines being cut by a transversal, L, M, N, if you state the lines involved in creating each angle, only the transversal is going to be common to both of the angles. But the actual lines that could be parallel are only going to be involved for one specific angle, you see? So if we're looking at a relationship between angles 1 and angles 20, then we're thinking about the potential of P and Q being parallel or not parallel. So if angle 1 is congruent to angle 20, how are those related? In terms of lines P and Q being cut by transversal L, well, those are alternate exterior angles. So if those are congruent, then that means line P is parallel to line Q. Okay, what if angle 3 is congruent to angle 10? Okay, well, you see vertical angles there, which is, it makes you think that we're not going to be able to conclude anything. But let's reason through this. So angle 3, creating the lines that create angle 3 are line P and line M, and the lines that create angle 10 are line P and line M. Yeah, we can't, there's no way, you have to have, if you're trying to determine if two lines are parallel, the angles that, every angle that we've talked about with the parallel theorems, it's always two angles that are on different vertices. Think about that. For all the theorems, the alternate interior, alternate exterior, trying to prove that two lines are parallel, It's always angles that are at separate vertices. So this tells us nothing. So there's no information, no basis here. Okay, what if angle 9 is congruent to angle 14? Angle 9 and angle 14. Okay. So, that looks like it's going to not give us any information either. So involved in creating angle 9 is line P and line M. And involved in creating angle 14 is line L and line Q. Yeah, there's no transversal here. They don't have any lines in common. Now, maybe if we had some information about how these angles are related to these angles, then we could kind of go from here to here, then from here to here. But with just saying that angle 9 is congruent to angle 14, we can't conclude anything. Okay, what if angle 7 is congruent to angle 11? Okay, well, with angle 7, you've got line P and L, create angle 7. With angle 11, lines P and N. Okay, so P is the transversal. Now, if we kind of turn our heads to the left here, we can see that we've got how are angles 7 and 11 related with P as a transversal. Those are corresponding angles. Both, like if you're looking up this way, it's top left, top left. Corresponding angles are congruent, so that means that line L is parallel to line N. Okay, yeah, here we go. So we got some perpendicularity constraints, which we also know can determine if lines are parallel. So if L is perpendicular to P and N is perpendicular to P, then L must be parallel to N. If you've got two lines in a plane and they're both perpendicular to the same line in that plane, then those two lines have to be parallel. There's no other way. It's not possible to have, you have one plane and you've got one line and another line, and then in that same plane, you draw a line that is perpendicular to both of those lines. That's not possible unless the two lines are parallel. So look, we'll make this, that's perpendicular. They have to be parallel. Okay, if L is parallel to M and M is parallel to N, then does that give us information about other lines that must be parallel? Well, yeah, we know that L must be parallel to N. We talked about why this is the case. If this is the symmetric property of parallelism, like, so if we know, like with numbers in equality, if A is equal to B and B is equal to C, then A is equal to C. Well, it works the same way with parallel. If A is parallel to B and B is parallel to C, then A must be parallel to C. And again, we in the textbook section, we talked about why this is the case. Okay, if L is perpendicular to P and M is perpendicular to Q, then what does that tell us? So L is perpendicular to P and M is perpendicular to Q. Well, that doesn't tell us anything. That gives us no information because, okay, you can think about this. At least in terms of being two lines being parallel. So, okay, let's draw a perpendicular here and a perpendicular here. Okay, so we've got L is perpendicular to P, and then M is perpendicular to Q. But clearly, none of these lines are parallel. No, so does that mean that the conclusion is that none of the lines are parallel? Well, no, I could have drawn it to where L is parallel to Q and P is parallel to M, and this is still satisfied. So this doesn't tell us anything here. None or no basis for anything. Okay, if angles 8 and angles 9 are supplementary, what does that tell us? Okay, angle 8 is made by lines P and L, and angle 9 is made by lines P and M. So P is the transversal. We've got interior angles on the same side of the transversal. And if those are supplementary, then we know that means parallelism. And so what lines are parallel? That would be lines L and M. Okay, if the measure of angle 8 is 110 degrees, P is parallel to Q, and the measure of angle 18 is 70 degrees. Okay, interesting. So angle 8 is created by lines P and L, and angle 18 is created by lines Q and N. Okay, which would normally mean it doesn't give us any information, but they give us something else here. They say lines P and Q are parallel. So if lines P and Q are parallel, and we've got some information about angle 8, then we can relate that to these angles here. So if lines P and Q are parallel, cut by transversal L, then we know that, let's see, angles 8 and angles 14 are supplementary. They must be. So how does that relate to angle 18? Because we've got line Q as a transversal cutting across L and N. So those would be what? Corresponding angles. 14 would correspond to 18. So, okay, let's see what we can figure out what angle 14 must be. So the measure of angle 14 must be 180 minus 110, which is 70 degrees. Okay, now, but angle 14 and angle 18 are corresponding with respect to Q cutting across line L and N. So how does angle 14 relate to angle 18? We know angle 14 measures 70 degrees. Well, they give us the measure of angle 18, so we can see angle 14 is congruent to angle 18, which proves that lines L and N are parallel. Okay, the bisectors of angle 9 and angle 21 are parallel. So angles 9 and angles 21, if we think about the bisectors of these angles, so those two lines are parallel. Okay, so we can see those two parallel lines are going to be cut by the transversal M. Let's put that in so we can see it clearly. Okay, so we know that this angle and this angle are congruent because they're bisected. And then based on vertical angles, this angle and this angle, these are all congruent. Now, these are congruent in the same way, but not necessarily the same as, they aren't the same as these angles, right? They didn't say anything about like angle 21 and angle 9 being congruent. Okay, but now if we look, so we've got this parallel line, this transversal. It's kind of hard to see. Let me change colors here. This is an interior angle, and this is an interior angle, right? And this is an exterior angle, and this is an exterior angle. So it's kind of weird looking because you have this big obtuse angle as one of the interior angles. So, okay, we've got an interior angle here, and then on the other side of the transversal, you've got an interior angle here. Those are alternate interior angles. So these two angles are congruent, which means, but then like, okay, we got vertical angles here, so those are congruent. So what this means is that actually all of these angles are congruent. So this angle and this angle are the same. These are all the same angle, okay? Now with that, if we look at line P and line Q and think about line P and line Q cut by transversal M, then take a look at this. So if we compare this angle and this angle, again, this is corresponding to transversal M going through lines P and Q, not the parallel bisectors. Well, those two angles are congruent, right? It's just the sum of this angle and this angle, but that's the exact same thing over here. So that's alternate interior angles that are congruent between line PQ and transversal M. And so that's all we need to say that line P is parallel to line Q. Determine the value of X so that line L will be parallel to line M. Okay, so if the measure of angle 4 is 5x and the measure of angle 5 is 4 times x plus 5, then what must x be to ensure that lines L and M are parallel? Well, these two lines are cut by transversal T, and angles 4 and 5 are alternate interior angles. So if these two measures are equal, then lines L and M will be parallel. So let's set these two expressions equal. So we've got 5x is equal to 4x plus 20. Subtract 4x from both sides, so x must be equal to 20. Okay, here they give us a relation for angle, the measure of angle 2, the measure of angle 7. So we can see those are alternate exterior angles. So if those angles were congruent, then lines L and M would be parallel. So let's set these equal to 0 and solve this equation for x. 5x minus 15. Subtract 4x from both sides. Add 15 to both sides. So x needs to be equal to 18. Okay, so if the measure of angle 3, they give us is x over 2. And they give us also an expression for angle 5. Those are interior angles on the same side of the transversal. So if those are supplementary, then lines L and M will be parallel. So that means supplementary means the measure of angle 3 plus the measure of angle 5 needs to be equal to 180. So if we multiply this entire equation by 2, we get x plus 2x is equal to 360. So 3x is equal to 360. Divide both sides by 3. Let's see, that would be 120, I believe. Let me make sure. Yes, x needs to be equal to 120. Okay, they give us a relation between angles 1 and angles 5. Those are corresponding angles, top left, top left. So these angles, their measures need to be equal for lines L and M to be parallel. So let's multiply this entire equation by 4. So this, we get 2x, 35 times 4. 4 times 3 is 12. It's 140. Okay, subtract 2x from both sides. You get x is equal to 140. Okay, here they give us a relation between angles 6 and angles 2. We see that those are corresponding angles, top right, top right. So those angles, their measures need to be equal to each other for lines L and M to be parallel. So x squared minus 9 needs to be equal to x times x minus 1. So distribute this x, subtract x squared from both sides, multiply both sides by minus 1, so x needs to be equal to 9. Okay, angles 4 and angles 5 are alternate interior angles, so these measures need to be equal. We need to set these two expressions equal and solve for x. So we've got 2x squared minus 3x plus 6. Distributing the 2x, you get 2x squared minus 2x, and then minus 2. The 2x squareds subtract out. Now we can add 3x to both sides. Minus 2x plus 3x is x. Now we can add 2 to both sides, and we get x is equal to 8. Okay, angles 3 and angles 5 are interior angles on the same side of the transversal, so we need these two angles to be supplementary for L and M to be parallel. So x times x plus 1, or no, x plus 1 times x plus 4, that value, and we can look at it this way. We can, just to make this clear, so let's write the measure of angle 5 here. Right? This is some, when you input an x, you get some value here. When you input an x, you get some value here. You take that value, well, no, okay, I'm going to say this entire value, that's the measure of angle 3 once you input an x, plus this entire value, once you input an x, that needs to be equal to 180 because these two angles need to be supplementary. So, okay, let's distribute this here. We've got x squared plus 4x plus x is 5x plus 1 times 4 plus 1 times 4 is 4, okay. Now plus 16x plus 16 times 3 is 48. Then minus x squared, then plus 2 is equal to 180. Okay? X squared minus x squared subtracts out. 16x plus 5x is 21x. 48 plus 4 is 52. 52 plus 2 is 54. Okay, 180 minus 54 is 126. So subtract 54 from both sides. Now divide both sides by 21. So let's see, 21 times 126. 21 times 6 is what? 126. So, okay. X is equal to 6. Okay, angle 2 and angle 8 are exterior angles on the same side of the transversal. So these two need to be supplementary. So we can think about, we've got this entire measure of this angle here, of angle 2, and then add that to this entire measure here of angle 8, and that needs to be equal to 180. So, okay, let's distribute this here. X cubed plus x squared minus x minus 1 plus 185 minus x squared minus 1 is equal to 180. So, okay, let's see. The x squared subtract out. We've got x cubed minus x. Then minus 1 is minus 2. 185 minus 2 is 183. Now subtract 183 from both sides. You get positive 3 on this side, so we can do this. So let's see. X cubed plus x squared minus x minus 1, and then 185. Oh, wait, no, this is x cubed. Yeah, wait a minute, hold on. I wrote this wrong here. So 185 minus x squared times x plus 1. There we go. Okay, so x cubed plus x squared minus x minus 1 plus 185 minus x cubed minus x squared. There we go. The x cubed subtract out, the x squared subtract out, and then you've got minus x, then plus 184, it's minus 1 plus 185. Now subtract 184 from both sides. Now multiply both sides by 1. So x needs to be equal to 4.